Okay, and then we'll basically, do the practicals later. So, so when we talk about networking, okay, let's start off with physical networking right now. Okay, and then we'll basically talk about the virtual networking. So in physical networking, what would happen is that you will have a desktop at home. Okay, now that desktop will basically have a network card, a physical network card you would have. Let's say at your home, you have a physical switch. Okay. Now what would happen is you will plug a cable from the switch to your router. Okay. Now the switch will be connected to a router. Okay. Router is connected to ISP, and then you are able to basically open google.com. That is how it works, right? Now, the switch that you have at home, it can support multiple devices. For example, if you have a PlayStation at home, or if you have an Xbox at home, okay, you can basically connect a cable. Let's say this is a PS5 that you have. You can connect a cable from the PS5 and it can go to the switch and it can also get the internet connectivity. Nowadays, TVs also have a switch port. You can plug a cable from the TV to the switch and that can have the connectivity. You can have a laptop. You can have a server at home. You can have a CCTV at your home. There are so many devices now that can basically connect to your switch and they all can get connectivity to the internet. Okay. Everyone can basically get connectivity to the internet. Now, if you think about it for a moment over here, this is your physical desktop. Okay. This is a physical network card. This is a physical cable that you have. This is a physical port where the cable gets connected. Okay. And then you have a physical switch over here. And then you have multiple devices connecting over here. Okay. If on your desktop, if you had two network cards, then this would have required its own separate port. Okay. Because every cable that you connect to the switch will require its own dedicated port, right? So this is the way it works in a physical environment, that you can have multiple devices all connecting to a switch, and switch will have connectivity to the router, and router will basically have connectivity to the ISP, and then you are able to basically go out to the internet. Okay. Now, physical switch that you have in your environment, it will not say that PS5 you are not allowed to go to the internet, or it will not say TV that you are not allowed to go to the internet. Basically, a switch will allow the connectivity. It does not care that the traffic is coming from a TV, from a desktop, from a laptop, or from a gaming console. It doesn't care. It will say that till the time you are sending the packet in the right framework, I will allow the connectivity to happen, and then it will let the connectivity go through. This is how it happens in a physical environment. So you can have multiple sources. Your source can be a desktop, computer, laptop, gaming device, television, whatnot, right? And they all can get internet connectivity. This is how it works in the physical environment. Any questions over here? Okay. Now let's change this, or let's virtualize this and think about from the VMware point of view. Okay. Like you have a physical switch in your environment, you have a virtual switch. Okay. Like you have a physical cable that you connect. Okay, you have to imagine a virtual cable over here. I mean, of course, you would not be able to see a virtual cable. So that is why you have to imagine over here that there is a cable connecting over here. Okay. On the switch, you have multiple ports, right? And these are physical ports that you have. Here, you would have to imagine that here you get virtual ports. Okay. Here, you have, and connectivity. I mean, you have connectivity to a router, and then you can basically send the traffic. Here, again, the same thing will happen. Here you would also have connectivity to a router, and then only you will be able to go to the internet. Okay. So the way physical environment works, exactly you are replicating it or you are changing the object into a virtual component. That is how it basically works over here. Okay. Now, when we were talking about physical environment, okay, therein I showed you that how the connectivity would happen and how things will work. Now, when we talk about networking on ESXi, okay, when we talk about networking on ESXi, so there are two software modules that will basically help you in doing this. There is something called as VSS, which is called VMware Standard Switch. Okay. And then you have a different module, which is called VDS, VMware Distributed Switch. Okay. So think about it. If you have a desktop at home, okay, and if I ask you to open google.com, either you will plug an internet cable, from the desktop to your router or modem, or you will have a Wi-Fi dongle, and then, via the Wi-Fi dongle, you will be able to connect to the internet. But either it will be wired connection or it will be a wireless connection for you to go to the internet. Similarly, when it comes to networking on ESXi, you have two modules over here. The first software module is referred to as standard switch, and the second module is basically referred to as distributed switch. So these are two different modules that you have that you can use to establish the networking on the ESXi. Now remember, these are two different modules. They are not interdependent. Okay. So it's not like to use a standard switch, you need a distributed switch, or to use a distributed switch, you need a standard switch. No. These are two independent options. Like when you buy a phone, you can get an Android operating system or you can get an, iOS, that Apple's one. Okay. Now these are two options that you have and they are completely independent. Okay. Neither Android is dependent on iOS nor vice versa. Right. So these are two different independent modules that you have. Now to establish the connectivity, you can use only the standard switch or you can also use the distributed switch as you feel it. You can use that. Okay. We will basically begin by talking about standard switch. Okay. And then we will talk about distributed switch, um, you know, later. So first, let's understand what a standard switch is and why this is needed. So remember, this is the default switch. That is, whenever you install ESXi at the on-prem, on the cloud, you know, you install one ESXi or you install 100 ESXi's, by default, you will get a standard switch for the networking. This is the default configuration. This is available with every license. So any license that you have from VMware, okay, it doesn't matter. This will be available by default. So standard switch is available by default and it comes with every license. Okay. Now, this is very basic to set up. Okay, you will not have a lot of advanced functionalities over here, or you will have nothing fancy over here. Okay, remember, you will have very basic functionalities, very limited networking options to basically configure. Nothing fancy, nothing out of the box, magical blue you're going to get over here. Absolutely no. Okay, very basic functionalities you're going to get over here. Now, this is very easy to understand. This configuration, when you will start doing in networking, you will see that, this is very easy to understand and to basically incorporate. And this works on per host level. So for example, if you have to add a VLAN, right? In networking, we have a very basic concept of a VLAN wherein you basically make the changes or you segregate your IP addresses based on the VLAN, right? Now, You will have a VLAN, for example, 100 that you have to create on your VMware environment. Now, if you are using a standard switch, and let's say if you have 96 ESXi's in your cluster and you have to add a VLAN 200, then this has to be added manually on every ESXi. Okay. So the networking change that you will do is only relevant on one ESXi. So that is why we say that standard switch is based on per host. That means on every ESXi, you will have to do the configuration. So in your cluster, if you have 96 ESXi's and if you have to add VLAN 200, you will have to do that configuration 96 times. Okay. If you know scripting, great. You can script it and you can do the scripting method. If you don't know scripting and if you want to do this manually, then you will have to do this 96 times. Okay. So this is what, in a nutshell, a standard switch is. Now, let's look at the console and understand that how we set up networking. So basically, when you have to set up networking, you do the configuration on the ESXi. Okay. So on the ESXi, you basically need to go to the configure tab. Under networking, you see these four options over here. And these four options basically do anything and everything. So entire networking is basically managed from these four options over here. Let's start off with physical adapter. Let's understand what a physical adapter is, why this is needed, and what it basically tells us. Okay. So when you talk about a physical adapter, this basically means in plain English that on your ESXi that you have, the HP server that you bought, okay, how many physical network cards are there? How many physical network cards are there on that HP server? This is what you will see in physical adapter screen. Okay. So if you have an HP server with 10 network cards, so 10 options will come up over here. If you have HP network card with 4 network cards, physical network cards, 4 of them will come up over here. If you install any external network card, let's say after buying the server, you basically bought a 100 Gbps network card and later you installed it. Now remember, this 100 Gbps card will only get recognized if you have the right drivers. If you do not have the right drivers, this 100 Gbps network card will not get recognized. Okay. So all the network cards which are basically getting recognized by the ESXi, you will see them under physical adapters list. This is the tab where all the physical network adapters on an ESXi are basically visible. Any questions on this tab? What physical adapters means over here? Okay. So now you see over here that it has a very unique naming convention. So it will not say that this is an HP network card or this is a Dell network card or this is a Intel network card. No, it is not going to say all that. It will only say VMNIC 0, 1, 2, 3, 4, 5, 6, 7, and so on. Okay. So every physical network card has a naming convention of VMNIC. So here you see I have got VMNIC 0, 1, 2, 3, 4, 5, 6, 7. That means I've got 8 physical network cards on ESXi 01. The naming convention by default will always be VMNIC, and then it will start with 0 and automatically it will keep incrementing it 1, 2, 3, 4, 5, 6 and so on. This naming convention I've been seeing since my childhood. Okay. So do not try to change this naming convention. If you see any blog on the internet or someone claiming that I know a hack on how to rename VMNIC 0 to, for example, ABC 0 or to Intel.0 or something, do not try to rename it. Okay. This is the way the card gets recognized. Since last 16 years, I've been seeing this. This is the naming convention they have had. So do not try to change this. Okay. This is the way your network cards will basically get recognized. Then here you see the actual speed, which is When you buy a network card, it comes with a network bandwidth that the network card is capable of sending the traffic at 1 gigabit per second or 10 gigabit. Earlier it used to be when I started working in 2010, it was 100 Mbps. The network cards were 100 Mbps back then. Now you have network cards of 400 Gbps. So it depends. I mean, whichever network card you are buying, what is their network bandwidth, you will basically see this configuration over here. Okay. Now, in the earlier days, what used to happen was that when you buy a server, so I'll give you an example, what used to happen earlier, that for example, you bought an HP server, okay? And on that HP server, for example, you have a 1 gig network card, okay? You have a 1 gig network card over here. Now, the problem is that the switch where this network card is getting connected, the port, this is of only 100 Mbps. So what would happen is you can send the traffic from 1 Gbps, but over here it will basically get bottled. Okay. Here you will have a traffic jam. Here you will have a bottleneck, wherein only 100 Bps, traffic will basically be pushed over here. Okay. So this used to happen 12 years ago or 13 years ago. This was a very common scenario. So what we used to do was we would intentionally change the speed of this network card to 100 Mbps because my switch did not support 1 Gbps. Okay. Now that's not the scenario. Okay. So nowadays, whatever network card you will have the same switch matching that configuration. That is why you see this configuration over here where it says configured speed. So configured speed basically means that though this card is of 100 Gbps or 10 Gbps, what is the configuration that you have set up over here? Okay. So by default, it will be the same that we have because that is very common now. Nobody changes it. Okay. You remember I was talking about that in your home, you have one physical switch, then you can have a second physical switch, a third physical switch, a fourth physical switch, and so on, right? And these physical switches are in physical world. In VMware, they basically are referred to as V switch. You have a P switch over here, and here it becomes a V switch. So similarly, you can also create multiple V switches. You can create a V switch 0, 1, 2, 3, 4, 5, 6. Now you can create a lot of V switches over here. Why do we create? What is the requirement? We'll talk about it. But for now, just understand like you have multiple physical switches, you can have multiple virtual switches as well. Okay. Then you have the MAC address. So any networking device in the world, okay, that gets manufactured, it has a burnt in MAC address. Okay. Without the MAC address, that networking device is not legal. It's an illegal device. Okay. Um, in India, there were, smartphones that used to come, 10 years ago or something that did not have any IMEI number. Every mobile phone is also having a specific number, to trace that number, same like the MAC address. So earlier you had these, smartphones, which did not have those numbers. Okay. So similarly, think about it like in phones, you have IMEI numbers. On a networking device, you will always have a MAC address. So on your phone, the Wi-Fi option that you get on the phone, the Bluetooth option that you get on the phone, that also has a MAC address. Okay. If you buy a network card from the market, uh, you know, the port, the networking port that you have on the PlayStation, on the TV, everything has a MAC address. Okay, that is the way it is. Without the MAC address, your networking device is not legal. It's an illegal device. Okay. What is DPU backed? I'll talk about it later. Not right now. I'll talk about it later. Now, what do you mean by observed IP range? Let me answer this question. So basically what happens is, let's say that you have an HP server And on that HP server, let's say that you have a physical network card. Okay. Now, this physical network card is getting connected to a physical switch on a port. Okay. Now, this port that you see over here will be associated with a VLAN. Every port has a VLAN number, which is then used to send across the traffic. So let's say this port is basically configured on VLAN 20. If the port is configured on VLAN 20, every VLAN has a CIDR. CIDR is the range of the IPs. So that means this could be 10.10.20.x/24. So this means, here I would have 254 IP addresses on the VLAN.